everyone, welcome back to Explore Electronics. In this video, let's see some very important questions for exam in digital system design using Verilog subject. Coming to module 1, in module 1, the very important two concepts are K-map simplification using K-maps for 3 variables and 4 variables and Quine-Maklowski minimization. If you learn these two concepts clearly, easily you will get 14-15 marks. Why? Because one question will be there on K-maps for 5 to 6 marks. Similarly, Quine-Maklowski minimization also there for 6 to 7 marks. So out of these two questions you will get 10 to 15 marks easily. And with that, so simplify the expression given using tabulation method. These three are very important and sure questions. And with that, you will get to identify the prime implicants, essential prime implicants, and some theory questions. What is SOP, POS, like that also some questions may be asked, but these are very important, repeatedly asked in the exam. In previous question papers also you can see these questions. This is module 1. Coming to module 2, logic design with MSI components and programmable logic devices. Here encoders, multiplexers, decoders are very important. They may ask to implement some function using a decoder, or they directly ask to explain 3 to 8 decoder, 4:1 mux, like that. And they may ask to implement higher order multiplexers using lower order. Like you can see here, 4:16 decoder using 2:4 decoder, 3:8 decoder using 2:4 decoder, like this. So the encoder 8:3 encoder is also very important. Priority without priority. 8:3 encoder with priority is asked many times in the previous exams. And coming to adders, carry look ahead adder, ripple carry adder is very important. And full subtractor is also important. Learn full adder, full subtractor from adders. And also 4-bit ripple carry adder and carry look ahead adder. Here you need to write the expressions clearly for sum, carry, and as well as propagate and generate signals. And then coming to PLDs, implementation using PLD is also a sure question. So you can expect one question from multiplexer, one question from encoder, one question from adder or subtractor, and one question is from implementation using PLD. Otherwise, you can also get one question on explain programmable logic devices and how to implement using those, like that. So you can easily score more marks in this module, since if you know multiplexers, encoders, and programmable logic devices implementation, it is very easy to score. Coming to module 3, it is on flip-flops and its applications. This is sequential circuit part. Here the very important question is flip-flops. They may ask to explain SR flip-flop, JK flip-flop, and they may ask to write characteristic equation and excitation table, and master slave flip-flop is also very important. And then they will ask to design one counter using flip-flops for sure. Design of mod counter or 4-bit counter using some JK flip-flop or T flip-flop, like that. You need to learn the design of counter by writing the table, current values, next values, or the next state. Then you need to implement the counter using that flip-flop. That is very important question. And also important question is ring counter and Johnson counter, and SISO, SIPO shift registers also may be asked. So here very important thing is flip-flops, master slave flip-flop, and design of mod counter or design of any bit counter. They may ask usually 4-bit synchronous or asynchronous counters, like that, and shift registers. Coming to module 4, module 4 is coding, Verilog programming. Here, starting from introduction to Verilog, they may ask to write the structure of Verilog module with an example. Here you can take simple example of half adder or full adder and explain what are all the things present in a Verilog module. And then this question rarely asked, you may get question importance of HDL for 4 to 5 marks. Write a note on different logical relational operators may be asked, and different data types. And this is very important, this 5th one. Write a Verilog code for 4:1 mux in data flow description. It is asked many times. And also 4:1 mux using 2:1 mux, like that they may ask to write the Verilog code. And this is module 4. It is very simple. You need to learn writing the Verilog code for simple designs like 4:1 mux, 2:1 mux, full adder, half adder, like that, and logical and relational operators and the structure of Verilog module is very important. Coming to module 5, it is behavioral description. Here in the behavioral description, there are assignment statement, how to write the sequential statements. There are looping statements, they are very important, how the loops are going to be written in Verilog. And then coming to multiplexers, again 4:1 or 8:1 mux will be asked to write using behavioral description. You can see here the second question, Verilog code for 4:1 mux, 2:1 mux, and also 8:1 mux you need to learn. And also positive edge triggered SR and JK flip flop using case statement is very important. You can expect question number 2 and 3 easily. And also write Verilog code for counter using case statement, and if else statement and nested if statement also very important, many times asked in the previous exams. And some other questions like ripple carry adder using structural description. And you can see here ripple carry adder is mentioned in the syllabus itself, so they may ask to write the ripple carry adder using structural description. So this is what module 5 is. So 4 and 5 are with respect to Verilog, so you need to at least they ask to write 2 to 3 Verilog codes, and some theory questions like explain operators, data types, and looping statements, if else with syntax they may ask. Any question they ask, you need to write with an example, that is giving more weightage to the answer. So this is about Verilog. And coming to module 1, 2, 3, you need to understand how to simplify the given expressions and how to implement using encoder, decoder, and mux and PLDs. And in module 3, how to design counter using and also flip-flops. This is about important questions for exam in digital system design using Verilog subject. Thank you.